Alright, so today we are going to discuss Laplace transforms. So as you can see here again, this is a table from the handbook, the EIT handbook. So we don't necessarily have to use the actual Laplace transform table. We can use the formula and work it out. Essentially, the transform is written in the S domain regardless of the independent variable. So the variable S is equivalent to a derivative operator, although it may be handled in the equations as a simple variable. So this is basically what it is. You can pretty much work it out that way, or you can use a table. So generally it is unnecessary to use the this formula right here. It takes too long anyway. That's why we have the table of Laplace transform. So I'm gonna do examples using the table. So problem number 1 here, find inverse of Laplace L of s equals 20s over s squared plus 20s plus 75. So we have to factor out the denominator. The product should give us 75, the sum should give us 20, meaning it's going to be s plus 5 times s plus 15 at the bottom. So 20s over s plus 5 times s plus 15 equals some types of constant at the top over s plus 5 plus another constant b over s plus 15. Now here we are using partial fraction. What you can't do essentially is don't do this, because right on top of your head you want to like separate the denominator without finding out what the numerator is supposed to be. So you would just flow into doing this like 20s over s plus 5 plus 20s over s plus 15. Don't do this. Never do this. So you got to separate it using a partial fraction method. And that's what we're going to do. So we're going to try to find a and b. This is simple. Just have to multiply out so using s plus 5 times s plus 15 as on the denominator, when you divide on top, a would be multiplied by s plus 15 and b will be multiplied by s plus 5, and you still have the denominator as s plus 5 times s plus 15. Alright, so we are going to multiply this out again. A times s is as, a times 15, 15a, plus b times s, bs, plus 5 times b is 5b, over denominator doesn't change, s plus 5 times s plus 15. Alright, okay, so we're going to put the s's together and the constant together. So that'll be a plus b times s, because we have as and bs, and then the constant would be 15a plus 5b. Again, denominator doesn't change, s plus 5 times s plus 15. So this equation equals, oops, I went too far. Trying to get it back here up. Okay. Alright, so the equation on the right side equals the equation on the left side. The denominator is the same, and so therefore the numerator should be the same. So we have to equal the numerators together. So on top we have 20s, and over here we have a plus b of s. So you know that in order for those to be equal, a plus b should be equal to 20. And then there's nothing after the 20s, so you know that 15a plus 15b gotta be 0. So we are equalizing the two equations together. Alright, so solving two equations and two unknown, we are left with pulling out a calculator. You can do it in a calculator. I don't know if the FE will allow you certain. I know there are certain calculators that are not allowed, but the FS series would be good for this type, and I think it's allowed in the room as well during the exam. So A equals minus 10 and B equals 30. You can solve it by hand as well. Alright, so we can go ahead and continue with our Laplace. Alright, so L of S would be minus 10, which is A, over S plus 5 plus B is 30 over S plus 15. So you can go ahead and use our table from here, because we had already simplified it. So we have Laplace of minus 10 over S plus 5 plus Laplace of 30 over S plus 15. Because the Laplace is like, when you have an addition is what they call that again? Commutative rule or something like that. So you can basically do that when you have an addition. You can't do it with a multiplication though. You have to work it out. But for addition, you can do it. So here for the table, we can recognize here that we have 1 over S plus alpha. In our case, we have at the denominator S plus 5. So we have minus 10, which is a constant, so that carries out. Minus 5t plus 30 e plus 15t. And that's it. That's our answer. Now in the EIT, we don't have to go through all of this stuff. I mean, you can do it in your head, but at the same time, it's just a matter of looking at the because it's multiple choice. So 2 of them would be gone right away. You can see. So I know I've spent a good 3-4 minutes with this problem, but we don't have to go through all of that stuff because it's multiple choice. So here, just as a reminder, our alpha was 5 for the first one and 15 for the second one. That's why we're using that particular equation. Okay, so I was saying because it's multiple choice for the EIT, you can stop somewhere and just recognize the answer. You don't have to work it, but even if you have to work it, it doesn't take that long. Alright, so let's work another problem. This is basically finding out Laplace. That was inverse of Laplace, so this is finding out Laplace transform given a t function. So we are expecting some s's. Like I was saying earlier, Laplace is commutative, so you can add, you can separate them. So you have L of u t minus 1 plus L of u t minus 2. So I've noticed that they don't necessarily have this this one in the table. The only thing they have is step at t equals 0, and they have equals 1 over s. But just so you know, we did this in class actually. We had this in class. So just as a reminder, when you have this at t equals c, we have e to the power minus cs. C is a constant over s. So applying this formula directly and recognizing that we have t equals 1 in our case here and t equals 2 in our case. So RC is equal to 2, so is equal to 1 and 2. So the first one would be e to the power minus s over s plus e to the power minus 2s over s. And that's pretty much it. If you want to go fancy, you can have it as a one denominator and add them up together. E to the power minus s plus e to the power minus 2s, and that's it. That one was pretty easy. Didn't take seconds, but yeah, it's pretty straightforward with Laplace. So this was just a reminder. So again, using the table, using your book, getting familiarizing yourself with it and applying the formula. That's pretty much it.